Alright, sorry about that. My lecture got locked out again as it was recording, and something, I don't know if I'm running out of memory or not. I gotta look into it. But anyhow, let's keep going here. Just so you know, we ended off with simplifying. Sorry, I backed up too much here. Example 9. We finished up right here before, and just being able to simplify. You know, sometimes you don't really need to expand through all of that. You can. This is a fairly simplified form. So just to wrap that one up, okay? But we should just walk through this real quick. All right, being able to do trig functions using the chain rule. All right, using U substitution. We use U substitution because that means there's an argument associated with the sine or the cosine or the tangent or anything else that's not just x. So we might have 5x or 10x, or cosine of like 12x, or sine of 2x, or sine of 4x, tangent of 8x. That kind of thing. There's an argument. It's not just sine of x or cosine of x or tangent of x, okay? So we will use U substitution. So when we take the derivative of sine of u, it will be the derivative of sine, which is cosine, and you keep the argument, times the derivative of the argument itself. So the derivative of the inside times the derivative of the outside. So the derivative of sine of u would be cosine of u times the derivative of u. Okay, so this is all showing U substitution. This is the same derivative we've been doing, so the trig piece doesn't change. All right, all the co's are still negative. All right, and nothing's changed there. It's just applying the chain rule using U substitution. So let's take a look at an example here. So if we look at A, right, we have y equals sine of 2x. Sine of 2x, that's the argument piece. Okay, so now we have to take that and make it U. So U will be 2x. So now when we use U substitution, you're going to take the derivative of sine of u, which is cosine of u times u prime, all right, or the derivative of u. So cosine of u, cosine is a derivative. So when we take sine of 2x, you're going to take the derivative of the sine of 2x, which is cosine of 2x, times the derivative of the argument. The derivative of 2x is 2. So it'll be cosine of 2x times 2, all right? So we end up with 2 cosine of 2x. All right, let's look at B. We have cosine of x minus 1. That's the argument. So the derivative of the outside times the derivative of the inside. The derivative of the outside would be taking the derivative of cosine. So the derivative of cosine is minus the sine of that stuff. All right, so minus sine of x minus 1 times the derivative of the inside. The derivative of x minus 1 is just 1. So we end up being negative sine of x minus 1 is our solution. All right. Let's look at the next one. We have tangent of 3x. 3x is our u, that's our inside stuff. So the derivative of the outside, which is the derivative of tangent, so the derivative of tangent is secant squared of 3x, so that's the derivative of the outside piece, times the derivative of the inside. The inside is 3x, so the derivative is 3x is 3, so we end up getting 3 secant squared of 3x. So there's really how we use the U substitution piece, or understanding that we're taking the derivative of the inside times the derivative of the outside. This is a composite function, okay, because the argument of the trig function has more than just x associated with it. You know, even if it was x, you would still use the chain rule, but the derivative of x is 1. So it would just be 1 times the derivative of the trig function. So that's why it works out perfect for all the normal trig functions. It's still a chain rule in effect, but we're multiplying by 1 because the argument is just x. So that's what makes it easy, okay? All right, just the last piece. All right, if you don't have the book with you or things like that, make sure that you write all this down. This is just a summary of all the rules that we went through, okay? Just general differentiation rules that we've done out of the past, 3 or 4 lectures. So make sure that you understand all these, write all these down, and have a nice sheet that shows you how to calculate all these, okay? But once again, guys, please tune into the live lectures that I got going on too. That really kind of helps solidify this down. I do a lot more examples, a lot more related to the homework as well. This is just a general, kind of overview of how we're taking some derivatives and things like that. But as usual, email me if you have any questions. Let me know if we need a team meet or Zoom meet or anything like that. Else, guys, have a great day. I'll see you in class.